हेलो दोस्तों, बिगनर्स माइंड में आपका स्वागत है। और अभी हम कर रहे हैं इकोनॉमिक्स। ठीक है, तो यहाँ तक कर लिया था। ये कंटिन्यूस सीरीज अब स्टार्ट करेंगे। इन केस ऑफ continuous series you have to locate the median class where n divided by second item not n plus 1 divided by 2 item lies. The median can then be obtained as follows: median L plus n divided by 2 minus CF upon F into H. L lower limit of the median class, CF cumulative frequency of the class preceding the median class. F frequency of the median class, magnitude of the median class interval. No adjustment is required if frequency is of unequal size or magnitude. Example 8. Following data relates to daily wages of persons working in a factory. Compute the median daily wage. Daily wage in rupees: 55 से 60, 50 से 55, 45 से 50, 40 से 45, 35 से 40, 30 से 35, 25 से 30, 20 से 25. Number of workers: 7, 13, 15, 20, 30, 33, 28, 14. The data is arranged in descending order here. In the above illustration, median class is the value of n divided by 2 item, that is 160 divided by 2 equals to 80 item of the series, which lies in 30 to 30, 35 to 40 class interval, applying the formula of the median. इसके बाद आ जाते हैं कंप्यूटेशन टेबल। Computation of median for continuous series. Daily wages in rupees. Daily wages in rupees 20 to 25. Number of workers 14. Cumulative frequency 14. 25 to 30 28. ये 42 ऐसे ही पूरा डाटा बन जाता है, और यहाँ पे 7 और 160। फिर आ जाते हैं मीडियन L प्लस n डिवाइड बाई 2 माइनस क्यूमुलेटिव फ्रीक्वेंसी डिवाइड बाई फ्रीक्वेंसी इंटू एच। ठीक, ये कितना आ जाएगा पूरा टोटल करके 35.83। Thus, the median daily wage is rupees 35.83. This means that 50% of the workers are getting less than or equal to rupees 35.83, and 50% of the workers are getting more than or equal to this wage. You should remember that median has a measure of central tendency, is not sensitive to all the values in the series. It concentrates on the values of the central items of the data. Quartiles are the measures which divide the data into four equal parts. Each portion contains equal number of observations. There are three quartiles. The first quartile, denoted by Q1 or lower quartile, has 25% of the items of the distribution below it, and 75% of the items are greater than it. The second quartile, denoted by Q2 or median, has 50% of items below it and 50% of the observations above it. The third quartile, denoted by Q3 or upper quartile, has 75% of the items of the distribution below it and 25% of the items above it. Thus, Q1 and Q3 denote the two limits within which central 50% of the data lies. Percentiles divide the distribution into 100 equal parts, so you can get 99 dividing positions, denoted by P1, P2, P3, P99. P50 is the median value. If you have secured 82 percentile in a management entrance examination, it means that your position is below 18% of total candidates appeared in the examination. If a total of 1 lakh students appeared, where do you stand? Calculation of quartile. The method for locating the quartile is same as that of the median in case of individual and discrete series. The value of Q1 and Q3 of an ordered series can be obtained by the following formula, where n is the number of observations. Q1 size of n plus 1 divided by 4 item. Q3 size of 3 n plus 1 divided by 4 item. Example number 9. Calculate the value of lower quartile. from the data of the marks obtained by 10 students in an examination 22, 26, 14, 30, 18, 11, 35, 41, 12, or 32. Arranging the data in an ascending order 11, 12, 14, 18, 22, 26, 30, 32, 35, 41. Q1 size of n plus 1 4. Item size of 10 plus 1 divided by 4 item. Size of 2.75 item. Second item plus zero point 0.5. Third item minus second item. 12 plus zero point 0.5. 14 minus 12 is equal to 13.5 marks. फिर आ जाते हैं मोड समटाइम्स. You may be interested in knowing the most typical value of a series or the value around which maximum concentration of items occurs. For example, a manufacturer would like to know the size of shoes that has maximum demand or style of the shirt that is more frequently demanded. Here, mode is the most appropriate measures. The word mode has been derived from the French word "la mode", which signifies the most fashionable values of a distribution, because it is repeated the highest number of times in the series. Mode is the most frequently observed data value. It is denoted by M0. Computation of mode. Discrete series consider the data set 1, 2, 3, 4, 4, 5. The mode for this data is 4 because 4 occurs most frequently twice in the data. Example 10. Look at the following discrete series. Variable 10, 20, 30, 40, 50. Frequency 2, 8, 20, 10, 5. Here, as you can see, the maximum frequency is 20. The value of mode is 30. In this case, as there is a unique value of mode, the data is unimodal, but the mode is not necessarily unique. Unlike arithmetic mean and median, you can have data with two modes, bimodal, or more than two modes, multimodal. It may be possible that there may be no mode if no value appears more frequent than any other value in the distribution. For example, in a series 1, 1, 2, 2, 3, 3, 4, 4, there is no mode. Unimodal data or bimodal data. Frequency, unimodal data or variable. Variable, bimodal data or frequency. Continuous series. In case of continuous frequency distribution, model class in the class with largest frequency. Mode can be calculated by using the formula MOL D1 divided by D1 plus D2 into H, where L lower limit of the model class, D1 difference between the frequency of the model class and the frequency of the class preceding the model class, ignoring signs. D2 difference between the frequency of the model class and the frequency of the class succeeding the model class, ignoring signs. H. Class interval of the distribution. You may note that in case of continuous series, class intervals should be equal and series should be exclusive to calculate the mode. If midpoints are given, class intervals are to be obtained. Example 11. Calculate the value of model worker family's monthly income from the following data. Less than cumulative frequency distribution of income per month in 000. Income per month or cumulative frequency. Less than 50 or 97, less than 30 or 60. Less than 15 to 4. As you can see this, in a case of cumulative frequency distribution, in order to calculate mode, you will have to convert it into an exclusive series. In this example, the series is in the descending order. This table should be converted into an ordinary frequency table, table 5.7, to determine the model class. Income group 000 rupees frequency 45 to 50, 97 to 95 2, 40 to 45 5, 35 to 40 10. The value of the mode lies in 25 to 30 class interval. By inspection also, it can be seen that this is the model class. Now L is equal to 25, D1 is equal to 30 minus 18 is equal to 12, D2 30 minus 20 is equal to 10, or H is equal to 5. Using the formula, you can obtain the value of the mode as M0 in 000, M0 L plus D1 divided by D1 plus D2 into H, 25 plus 12 into 12 divided by 12 plus 10 into 5, 27.273. Thus the model worker family's monthly income 27.273. फिर आ जाते हैं रिलेटिव पोजीशन ऑफ अर्थमेटिक मीन, मीडियन एंड मोड. Suppose we express arithmetic mean ME, median MI, mode MO. The relative magnitude of 3 are ME बड़ा होगा एम आई, फिर छोटा एम ओ, और फिर एम ई एम आई एम ओ, सफिक्स अकरिंग इन अल्फाबेटिकल ऑर्डर। द मीडियन इज ऑलवेज बिटवीन द अर्थमेटिक मीन एंड द मोड। फिर आ जाते हैं कॉन्क्लूजन। मेजर्स ऑफ सेंट्रल टेंडेंसी ऑफ एवरेजेस आर यूज टू समराइज द डाटा। इट specifies a signal most representative value to describe the data set. Arithmetic mean is the most commonly used average. It is simple to calculate and is based on all the observations, but is unduly affected by the presence of extreme items. Median is better summary for such data. Mode is generally used to describe the qualitative data. Median and mode can be easily computed graphically. In case of open-ended distribution, they can also be easily computed. This it important to select an appropriate average depending upon the purpose of analysis and the nature of the distribution. अब आ जाते हैं रिकैप। द मेजर ऑफ सेंट्रल टेंडेंसी समराइजेस द डाटा विद अ सिंगल वैल्यू which can represent the entire data. Arithmetic mean as defined as the sum of the values of all observations divided by the number of observations. The sum of deviations of items from the arithmetic mean is always equal to 0. Sometimes it is important to assign weights to various items according to their importance. Median is the central value of the distribution in the sense that the number of values less than the median is equal to the number greater than the median. Quartiles divide the total set of values into four equal parts. Mode is the value which occurs most frequently, ठीक है, और इसी के साथ इकोनॉमिक हो जाती है समाप्त।